The method for tightly sealing a container with a carbonated beverage was invented in 1892 by American inventor William Painter. His crown cork design prevented carbon dioxide from escaping, while the cork liner protected the drink from coming into contact with the metal surface. Today, PET bottles, in other words plastic bottles, are in high demand among consumers. Accordingly, the caps for them are different too. In manufacturing, they are called polymer screw caps with perforation and sealing liners. In everyday language, simply a cap. Let's take a look at how it's made. There are some peculiarities here. The thing is, PET bottle caps can differ. Single-component caps are cheaper and faster to produce. Two-component caps are of higher quality but also more expensive. If you've ever had to open a PET bottle with pliers, you can be sure that stubborn cap was a single-component one. They must be tightened very firmly. Otherwise, there would be significant losses of carbon dioxide. To avoid such issues, the two-component cap was invented. The heroes of this innovation are special PET liners that not only make the bottle easier to open, but also provide maximum protection against gas loss. At first, future caps look like this. This is the polymer, the raw material. It's loaded from bags into special injection molding machines. Here, a mandatory drying process takes place at 80 degrees C, 176 degrees for 2 to 4 hours. A three-component plastic cap consists of 3 separate parts, each manufactured independently on its own injection molding machine. 3 blanks are cast: the cap itself, the outer shell, and the screw or dosing insert. Each component requires its own specific raw material. We use materials such as polystyrene, polyethylene, ABS, or polypropylene. Using these polymers, we create the final cap. The purpose of drying the material is to prevent possible defects. Next, the raw material enters the injection unit, where it's heated to 270 degrees, 518 degrees. This process is known as plasticization. Essentially, the molding machine consists of 2 large plates, a movable and a fixed platen, which clamp together under a high pressure of 180 bar. The hot chamber of the injection mold is designed to ensure balanced cavity filling, optimal thermal distribution, and uniform density of the molten polymer. However, the polymer still needs to be cooled to 12 degrees C, 54 degrees Gas. This is done using a special cooling liquid, ethylene glycol. Each cycle lasts just 12 seconds, during which 32 blanks are produced. Our process works on the extruder principle, meaning a continuous supply of material. The material is fed through a nozzle continuously, and a rotating carousel distributes it to each extractor in the form of pellets. Knives at the bottom cut the material into equal tablets. A vacuum first holds each tablet in place on the knife. When the carousel turns to the correct mold, the tablet is blown into the center of the mold cavity with compressed air. This is called air injection. Then the forming process begins. By the way, to give the caps their specific color, plastic dyes are added during plasticization. The key here is maintaining the correct proportions. For cap production, we use both liquid and dry colorants. Liquid dyes are mixed using a premixer, while dry pigments are combined with the polymer in a special mixer according to precise ratios to achieve the desired shade. The color of the cap typically matches the label color on the bottle, so this process requires special attention and precision. The final shade is achieved by adjusting the percentage of colorant in the polymer mix. The next production stage is the decoration area. Here, 5 machines operate. 4 of them perform hot foil stamping. During the process, a heated die presses foil against the cap material, melting the separation layer and leaving the decorative image on the surface. A standard machine can emboss 2,500 caps per hour, while a high-speed one can handle up to 8,000. Another machine at this facility operates using the screen printing method. For decoration production, we have our own in-house laboratory equipped with a laser printer. This allows us to create any type of decoration requested by our clients. The lab also contains equipment for making stencils used in screen printing. We can produce 3-color prints, and for hot foil stamping, we can apply 2-color decorations. These 2 techniques, screen printing and hot foil stamping, can even be combined on a single cap. While the future cap is being decorated, the other components are waiting for it in the loading hopper of the assembly machine. Here, the second component is installed into the inner part of the cap. Finally, the finished product is packaged and sent off to another local manufacturer, a carbonated beverage company. But that's already another story, made in Kazakhstan.